Before penicillin, even small wounds could turn deadly. Bacteria, invisible enemies, caused infections that medicine couldn't cure. Simple cuts could lead to amputations. Childbirth, often a joyous occasion, carried the risk of fatal infections. The world desperately needed a solution. Doctors worked tirelessly, but their tools were limited. They could only watch as infections ravaged their patient. The discovery of bacteria had revealed the cause of these illnesses, but stopping them seemed impossible. The world awaited a miracle. In London, a Scottish scientist named Alexander Fleming toiled diligently in his lab day in and day out. Fleming was renowned for his meticulous and groundbreaking research on bacteria, which set him apart from his peers. He spent countless hours studying their growth and behavior, meticulously searching for ways to combat their harmful effects on human health. His dedication to the fight against infection was unwavering, driven by a passion to make a difference. Fleming's lab was his sanctuary, filled with petri dishes, microscopes, and the essential tools of his trade. He meticulously labeled his samples, carefully noting his observations with precision and care. His sharp mind sought patterns in the microscopic world, hoping to unlock the secrets of bacterial growth and behavior. His patience and persistence, working late into the night, would soon prove invaluable to the world of medicine. In 1928, Fleming returned from a vacation to find a peculiar sight in his lab. A petri dish containing bacteria had been left open accidentally. A strange mold had grown on the dish, contaminating his experiment. At first glance, it seemed like a setback, an annoyance. But Fleming, ever the keen observer, noticed something unusual. The area around the mold was clear. The bacteria had been killed. This mold, it seemed, possessed a powerful weapon against the deadly microorganisms. Fleming realized he might have stumbled upon something extraordinary. Section 4. The struggle for recognition. Fleming named the mold's active agent penicillin. He tested it further, confirming its ability to kill bacteria. Excited, he shared his findings with the scientific community, hoping for support to develop his discovery into a usable medicine. But his initial reports were met with skepticism. The process of purifying penicillin proved challenging. It was unstable and difficult to produce in large quantities. Many doubted its effectiveness. Funding was scarce, and progress was slow. Years passed, and Fleming's miracle mold remained largely forgotten, its potential unrealized. Section 5, penicillin to the rescue. World War II erupted, bringing with it a surge in battlefield infections. Soldiers were falling ill, not just from their injuries, but from the rampant spread of bacteria in the trenches. The need for an effective antibiotic became more urgent than ever. Hospitals were overwhelmed, and doctors were desperate for a solution to combat these deadly infections. Scientists remembered Fleming's discovery of penicillin and began working tirelessly to mass-produce this promising antibiotic. They knew it could be the key to saving countless lives. Their efforts were driven by the desperate need to save lives on the front lines. Every day, more soldiers were being brought in with severe infections that traditional treatments couldn't cure. Thanks to breakthroughs in production techniques, penicillin finally became widely available. Factories ramped up production, ensuring that this life-saving drug could reach those who needed it most. Soldiers with infected wounds, once destined for amputation or death, were now being cured. The transformation in their health was nothing short of miraculous. The impact was immediate and dramatic. Recovery rates soared, and the morale of both soldiers and medical staff improved significantly. Penicillin became known as the miracle drug, saving countless lives and changing the course of medical history. Its success marked a turning point in the fight against bacterial infections. Section 6, a legacy of healing. The discovery of penicillin ushered in a new era of medicine, transforming the landscape of healthcare forever. Bacterial infections that were once death sentences became treatable, giving hope to millions who previously had none. Surgeries became safer, and childbirth lost much of its former danger, significantly reducing maternal and infant mortality rates. Penicillin's success also spurred the search for other antibiotics, leading to the development of countless life-saving drugs that we rely on today. Fleming's accidental discovery revolutionized medicine, showing the world the potential of scientific research and innovation. It taught us that even the smallest observation can lead to breakthroughs that change the world, emphasizing the importance of curiosity and perseverance in science. Penicillin's legacy lives on in every life saved by antibiotics, a testament to the power of scientific curiosity and the enduring impact of a single, unexpected mold. This legacy continues to inspire new generations of scientists and healthcare professionals. At Pause 3S, Section 7, The Roots of Genius. Before Alexander Fleming became a name synonymous with medical breakthroughs, he was just a boy from a humble Scottish farm. Born in 1881 in Lochfield, Ayrshire, young Alec, as he was known, grew up surrounded by the rugged beauty of the Scottish countryside. His early life was marked by a strong work ethic and an insatiable curiosity about the natural world. Fleming's educational journey began in a small village school where his keen mind quickly stood out. Encouraged by his teachers, he moved to London to further his studies. It was there, at St Mary's Hospital Medical School, that Fleming's path truly began to take shape. He was a dedicated student, known for his meticulous nature and a passion for understanding the unseen forces that cause disease. In his early career, Fleming served as a captain in the Royal Army Medical Corps during World War I. Witnessing the devastating effects of bacterial infections on wounded soldiers, he became determined to find better ways to combat these invisible killers. His experiences on the battlefield instilled in him a profound sense of purpose and urgency that would drive his future research. Fleming's early life was not just a prelude to his later achievements. It was the foundation upon which his scientific genius was built. The lessons learned from his rural upbringing, combined with the discipline and resolve forged in the crucible of war, equipped him with the tools he needed to change the world. It's a reminder that greatness often has humble beginnings, and the seeds of innovation can be sown in the most unexpected places. As we reflect on Fleming's journey from a farm in Scotland to the annals of medical history, we see the enduring power of curiosity, perseverance, and the relentless pursuit of knowledge. His story is a testament to the idea that anyone, regardless of their origins, has the potential to make a profound impact on the world. Pause 3S. This concludes our exploration of Alexander Fleming's early life, a crucial chapter in the story of penicillin and a beacon of inspiration for future generations of scientists and dreamers alike. Pause 3S, Section 8. The Quest for a Cure. Alexander Fleming's journey from a dedicated student to a pioneering scientist was marked by relentless experimentation and an unwavering commitment to unraveling the mysteries of bacterial infections. At St Mary's Hospital, Fleming immersed himself in research driven by the urgent need to find effective treatments for the deadly infections plaguing humanity. Fleming's work initially focused on the properties of antiseptics and their effects on wounds. He conducted meticulous experiments to observe how various substances interacted with bacteria. Through countless trials and errors, he realized that many antiseptics, while effective on the surface, were often harmful to the deeper tissues, allowing bacteria to thrive and cause further damage. One of his significant discoveries during this period was the enzyme lysozyme. In 1922, Fleming noticed that a drop of his nasal mucus, when placed on a bacterial culture, caused the bacteria to dissolve. This serendipitous observation led to the identification of lysozyme, a natural antibacterial agent present in human secretions. Though lysozyme had limited therapeutic applications, it fueled Fleming's belief that nature held the key to combating infections. Despite these breakthroughs, the scientific community largely overlooked Fleming's work. However, Fleming remained undeterred. His laboratory became a hub of innovation, where he meticulously documented his findings and continued to experiment with various substances in the hope of discovering a more potent antibacterial agent. In 1928, Fleming's perseverance paid off in an unexpected way. Upon returning from a holiday, he noticed that a petri dish containing Staphylococcus bacteria had been contaminated by a mold. Intriguingly, the bacteria surrounding the mold were being destroyed, while those further away remained unaffected. This mold, later identified as Penicillium notatum, produced a substance that inhibited bacterial growth. Fleming named this substance penicillin. Fleming's next challenge was to isolate and purify penicillin. He faced numerous obstacles, including the unstable nature of the compound and the difficulty of producing it in large quantities. Nevertheless, his groundbreaking discovery laid the foundation for the development of the first true antibiotic, revolutionizing medicine and saving countless lives. Fleming's scientific process was characterized by a blend of curiosity, meticulous observation, and an openness to unexpected findings. His approach serves as a reminder that groundbreaking discoveries often arise from a willingness to question the status quo and explore the unknown. As we delve deeper into the story of penicillin, we see the profound impact of Fleming's dedication to scientific inquiry and his unyielding quest for a cure. Pause 3S. This concludes our examination of Alexander Fleming's scientific process and the experiments that led to the discovery of penicillin. His journey serves as an enduring inspiration for scientists and researchers, highlighting the importance of perseverance, curiosity, and the relentless pursuit of knowledge. Pause 3S. Section 9. The Dawn of Doubt. Despite Alexander Fleming's groundbreaking discovery of penicillin, the initial reactions from the scientific community were far from enthusiastic. The early 20th century was a time when the medical field was deeply entrenched in established practices, and skepticism toward unconventional methods was rampant. Fleming's announcement of penicillin in 1929 was met with a mixture of curiosity and doubt. Many of his peers were unable to grasp the potential of this new substance. The scientific journals of the time gave only modest attention to his findings, and the broader medical community largely dismissed penicillin as an impractical curiosity rather than a revolutionary breakthrough. The skepticism was not unfounded. Fleming himself struggled with the instability of penicillin, finding it difficult to produce in large quantities and maintain its potency. His early attempts to isolate and purify the compound were met with limited success, further fueling the doubts of his contemporaries. Moreover, the prevailing medical opinion was heavily influenced by the success of chemical antiseptics and the emerging field of synthetic drugs. The idea that a mold-derived substance could outperform these sophisticated treatments seemed far-fetched to many. Fleming's work, though meticulous, was overshadowed by the immediate practical applications of chemical antiseptics which were already widely accepted and used. Yet Fleming remained steadfast. He continued to document his findings, perform experiments, and refine his techniques. He understood that convincing the scientific community would require more than anecdotal evidence. It would necessitate rigorous proof and reproducible results. The turning point came when Fleming's work attracted the attention of Howard Florey and Ernst Boris Chain at the University of Oxford. These scientists recognized the potential of penicillin and took on the challenge of mass-producing and purifying it. Their efforts eventually led to the large-scale production of penicillin, proving its efficacy and transforming it into a cornerstone of modern medicine. The initial skepticism of the scientific community serves as a reminder of the challenges faced by pioneers in any field. Fleming's perseverance in the face of doubt underscores the importance of resilience and belief in one's work. It also highlights the collaborative nature of scientific progress, where breakthroughs often require the combined efforts of multiple visionaries. As we reflect on the journey of penicillin from a moldy petri dish to a life-saving antibiotic, we are reminded of the importance of open-mindedness and the willingness to challenge established norms. The skepticism that initially greeted Fleming's discovery was ultimately overshadowed by the undeniable impact of penicillin, forever changing the landscape of medicine. Pause 3S. This concludes our exploration of the initial reactions and skepticism faced by Alexander Fleming and his discovery of penicillin. The journey of penicillin is a testament to the power of perseverance and the transformative impact of scientific innovation. Pause 3S. Section 10. The War Effort. As World War II raged across the globe, the urgency for effective medical treatments became more pressing than ever. The battlefield injuries and infections that plagued soldiers demanded a reliable solution, and penicillin emerged as the beacon of hope. Pause 2S. The collaboration between Howard Florey, Ernst Boris Chain, and their dedicated team at the University of Oxford had already laid the groundwork for the mass production of penicillin. However, it was the war effort that accelerated the process, transforming penicillin from a laboratory curiosity to a frontline necessity. Pause 2S. In 1941, the United States and the United Kingdom joined forces in a monumental effort to scale up penicillin production. The War Production Board in the United States spearheaded this initiative, enlisting the help of pharmaceutical companies like Pfizer, Merck, and Eli Lilly. These companies, driven by a sense of duty and patriotism, dedicated their resources to refining the fermentation process, increasing yields, and ensuring the stability of penicillin. Pause 2S. The results were nothing short of miraculous. By D-Day in 1944, enough penicillin had been produced to treat thousands of wounded soldiers. The drug's impact was profound, reducing the mortality rate from bacterial infections and saving countless lives on the battlefield. Penicillin became known as the miracle drug, its reputation spreading like wildfire among the troops and medical personnel. Pause 2S. The mass production of penicillin during World War II also marked a turning point in pharmaceutical manufacturing. The techniques and technologies developed during this period set new standards for drug production, paving the way for the modern pharmaceutical industry. The collaboration between scientists, government agencies, and private companies showcased the power of unified effort in the face of global challenges. Pause 2S. As the war drew to a close, the legacy of penicillin extended beyond the battlefield. The drug became widely available to the general population, revolutionizing the treatment of bacterial infections and ushering in a new era of medical possibilities. It was a triumph of science, collaboration, and human ingenuity. Pause 2S. Reflecting on this period, we see how the exigencies of war can drive rapid innovation and bring out the best in humanity. The mass production and distribution of penicillin during World War II stand as a testament to our ability to overcome seemingly insurmountable challenges through collective effort and determination. It is a story of hope, resilience, and the enduring impact of scientific discovery. Pause 3S. This concludes our examination of the mass production and distribution of penicillin during World War II. The efforts to bring this life-saving drug to the front lines not only changed the course of the war, but also transformed the landscape of modern medicine forever. Pause 3S, Section 11. The modern medical marvel. As the dust settled from the ravages of World War II, penicillin's journey was far from over. The post-war era saw this miracle drug transition from the battlefields to civilian hospitals, heralding a new age in medical treatment. Pause 2S. The widespread availability of penicillin transformed the medical landscape, turning once lethal infections into manageable conditions. Diseases like pneumonia, sepsis, and rheumatic fever, which had claimed countless lives, were now treatable. This newfound ability to combat bacterial infections saved millions of lives and drastically reduced mortality rates worldwide. Pause 2S. The impact of penicillin extended beyond treating infections. It paved the way for the development of other antibiotics, each more powerful and targeted than the last. Researchers inspired by the success of penicillin embarked on a quest to discover new antimicrobial agents, leading to breakthroughs that have shaped modern medicine. Pause 2S. Penicillin also revolutionized surgical procedures. Before its advent, even minor surgeries carried significant risks of infection. With the introduction of antibiotics, surgeons could perform more complex and invasive procedures with confidence, knowing that post-operative infections could be effectively managed. This advancement opened new frontiers in medical and surgical care, enabling life-saving operations and improving patient outcomes. Pause 2S. Moreover, penicillin's role in saving lives has had a profound societal impact. It has contributed to increased life expectancy, improved quality of life, and reduced healthcare costs. The ability to treat bacterial infections has also played a crucial role in the success of public health initiatives, such as vaccination programs and the management of infectious diseases. Pause 2S. The story of penicillin is not just one of scientific triumph, but also of human resilience and ingenuity. It underscores the importance of research, collaboration, and innovation in overcoming health challenges. The legacy of penicillin serves as a reminder of what can be achieved when the brightest minds come together with a common purpose. Pause 2S. Today, as we face new and emerging health threats, the lessons learned from penicillin's development and distribution remain as relevant as ever. It is a beacon of hope, illustrating the power of scientific discovery to transform lives and shape the future of medicine. Pause 2S. In reflecting on the journey of penicillin, we celebrate not just a drug, but a symbol of humanity's unyielding quest to conquer disease and improve health. It stands as a testament to the enduring impact of scientific innovation on the world, reminding us that with determination and collaboration, we can overcome even the most formidable challenges. Pause 3S. This concludes our exploration of penicillin's profound impact on modern medicine. Its legacy continues to inspire and guide us as we navigate the ever-evolving landscape of healthcare, striving to achieve a healthier and brighter future for all. Our Pause 3S Section 12, the future of antibiotics. As we continue to build on the foundations laid by penicillin, the pursuit of new antibiotics remains a critical endeavor in modern medicine. The battle against bacterial infections is far from over, and researchers around the world are tirelessly working to stay ahead of evolving pathogens. Pause 2S. The rise of antibiotic resistance poses one of the greatest challenges of our time. Bacteria that were once easily eradicated by penicillin and its successors are now developing resistance, rendering some treatments ineffective. This alarming trend has prompted a renewed focus on antibiotic research, with scientists exploring innovative strategies to outsmart these resilient microbes. Pause 2S. One promising avenue of research involves the development of next-generation antibiotics that target specific bacterial mechanisms. Unlike broad-spectrum antibiotics, these targeted treatments aim to minimize collateral damage to the body's beneficial bacteria, reducing the risk of resistance. Advances in genomics and molecular biology are enabling researchers to identify new bacterial vulnerabilities, paving the way for more precise and effective therapies. Pause 2S. In addition to discovering new antibiotics, scientists are also exploring alternative approaches to combat infections. Phage therapy, which uses bacteriophages, viruses that infect and kill bacteria, offers a novel solution to antibiotic resistance. This method, once overshadowed by the success of antibiotics, is experiencing a resurgence as researchers uncover its potential to treat resistant infections. Pause 2S. Another innovative strategy involves harnessing the power of the immune system. Immunotherapies that boost the body's natural defenses against bacterial invaders are being developed, providing a complementary approach to traditional antibiotics. By enhancing the immune response, these therapies aim to reduce the reliance on antibiotics and curb the spread of resistance. Pause 2S. The search for new antibiotics also extends to the natural world. Scientists are scouring diverse ecosystems, from deep-sea vents to remote rainforests, in the hope of discovering novel compounds with antimicrobial properties. Nature's vast biodiversity holds untapped potential for new drugs, and advances in technology are making it possible to explore these hidden treasures more effectively than ever before. Pause 2SS. Collaboration and global cooperation are essential in the fight against antibiotic resistance. Governments, healthcare organizations, and research institutions are joining forces to share knowledge, resources, and expertise. Initiatives like the World Health Organization's Global Action Plan on Antimicrobial Resistance underscore the importance of a united effort to address this urgent issue. Pause 2S. The future of antibiotics is a story of resilience, innovation, and hope. While the challenges are formidable, the spirit of scientific inquiry and the determination to protect public health continue to drive progress. By building on the legacy of penicillin and embracing new technologies and approaches, we can rise to the challenge and secure a healthier future for generations to come. Pause 3S. This concludes our exploration of the ongoing research and development of antibiotics inspired by penicillin. As we look to the future, let us remain committed to the pursuit of knowledge and the quest for solutions that will safeguard the health and well-being of our global community. Thank you for joining us on this journey through the remarkable history and promising future of antibiotics. Together we can conquer the challenges ahead and continue to advance the boundaries of medical science. Pause 3S.